we're going to look at solving radical equations. Now before we get into the steps that you're going to use, we're first going to look at what's happening behind the scenes here. So what's really going on? And if I were to start with an radical, like x to the 3/4 power is equal to 8, what you want to think about is, what does being raised to the 3/4 power really mean? Well, that's the same thing as saying the fourth root of x cubed. Now if we just use our algebra background, we can solve this problem. And what you have to think about is, I need to get rid of this fourth root. Well, to undo the fourth root, I would need to raise it to the fourth power. So I would need to raise both sides of my equation to the fourth power. That would cancel those out. So then I would be left with x cubed is equal to 8 raised to the fourth power. Now in order to get x by itself, I have to get rid of this cubed. In order to get rid of cubed, I would need to do cubed root. So I would have to cubed root both sides. Those would cancel out, and I would be left with x equals the cubed root of 8 raised to the fourth. Now I could rewrite this as 8 raised to the 4/3 power, and then continue to simplify it from there. But what I want you to look at is, look at my exponent here, and look at what I started with. Notice that they are reciprocals of each other. So when I start with x to the 3/4 power, in order to completely get rid of it, I need to raise everything to the 4/3 power. Now if we use our rules of exponents to look at why that happens, when I have a power of a power, I multiply my exponents. So if I took 3/4 raised to the 4/3, I would end up with x raised to the 12/12, which in turn is just x. That is what I'm always trying to solve. So when we're solving radical equations, there's a 3-step process that we really need to do. The first thing we need to do is to isolate the radical or the variable. And what that means is to get it by itself. If there's 2 radicals, then isolate one of them and we'll work from there. Second thing you're going to do is what I just showed you. You're going to raise both sides of the equation to the reciprocal power of the rational exponents. So in that last example, x was raised to the 3/4. We had to raise everything to the 4/3. And then the third thing, this one becomes so important when you are doing radical equations. You have got to check all your answers. The reason for this is because you can do all the steps right, you can have your math perfect, but you can come up with an extraneous solution, which basically means it's a false solution. So here's our first set of practice examples. On the left here, we have 3x to the 2/3 equals 375. Now, first thing I have to do is figure out, where is my radical? And my radical is right there, the x to the 2/3. This 3 is not attached to my radical. In order to be attached to the radical, there would have had to have been parentheses around the 3 and the x to show that they were a unit hooked together. So, first step is isolate my radical. I have got to divide both sides by 3 in order to get that radical completely by itself. Once I get it isolated, I have the x to the 2/3 is equal to 125. Now I've got my radical isolated, so I can go ahead and raise it to the reciprocal power. Now my reciprocal power for this one would be 3/2, because the reciprocal of 2/3 is 3/2. So I need to raise both sides of my equations to the 3/2 power. On the left side, my power of power rules would give me x raised to the 6/6, which is just x, so these exponents essentially cancel each other out. And on this side, I end up with 125 raised to the 3/2. Now I have to see if I can simplify this down. So I'm going to go ahead and rewrite this as the square root of 125 cubed. And what I want to do first is see if I can break down the square root of 125. And from your little cheat sheet, you would break down the 125 into the square root of 25 and the square root of 5. And that would simplify down into 5 square roots of 5. Now that only takes care of the square root portion. We still have this third power hanging out on the outside here. Now, raised to the third power means I really have 5 square roots of 5 times 5 square roots of 5 times 5 square roots of 5. Well, all my regular 5's out in front, those can be multiplied together to give me 125. And then the 5's underneath the radical, since they're the same radical, I can go ahead and combine those, multiply those together, and get the square root of 125. Now notice I ended up with a square root in my answer, so I have to check again if I can break down that square root of 125. And it'll break down the same way it did up here. So I'd break it down into the square root of 25, square root of 5. So now I have 125. My square root of 25 is just 5. Square root of 5 I leave alone. And then go ahead and multiply the 125 times 5, and you would get 625 square roots of 5. Now you might think you're done right there, but you have got to check your answers. And in order to do that, you are going to take your calculators and you're going to type in 3 times the quantity, 625 square roots of 5, and then you're going to do the raise to button, and most of you will have to use parentheses at this point and put in 2/3. Now when I type that into my calculator, I come out with exactly 375, so I know that this answer is a good answer. We can keep that answer. The second problem over here, follow the same types of steps. I first need to isolate my radical. Well, here is my radical. It's a cubed root. This minus 5 is not part of my radical, so it has to go. So I'm going to add 5 to both sides. And on the left, I would be left with the cubed root of 2x is equal to 16. Now, I've got to change this into a fractional exponent because in order to find the reciprocal, I need to know what my fractional exponent is. Cubed root is really the 1/3 power. Now that I have it rewritten, I can go ahead and figure out what my reciprocal is. And my reciprocal would be raised to the 3/1. So each side is going to get raised to the 3/1, which is just the third power. On the left side, those will cancel out, so I would just be left with 2x. And on the right side, I would have 16 cubed. Now I'm going to go ahead and multiply out that 16 cubed, since there's no variables in it, and that is 4,096. Okay, I'm not quite done yet. I still have a 2 hanging out over here with my x, so I need to divide both sides by 2, and I get x is equal to 2048. So 2048. Again, I have got to go back and check this. So I would type in my calculator the cubed root of the quantity, 2 times 2048 minus 5. And when I type that in my calculator, it gives me back an 11, so I know I'm okay with it. Okay, here's 2 more practice problems that have a little different style. The one on the left, we've got our radical isolated already. I'm just going to go ahead and rewrite it as a fractional exponent instead of leaving it as a radical. And now, as I look at that, the reciprocal of the 1/2 power would be raising it to the second power. So I've raised both sides to the second power. On the right side, the 1/2 and the second power cancel each other out, so we have 2x. On the left side, you hopefully recognize that this is a FOIL problem. Don't get caught distributing that square. You can only distribute that square to everything inside when it's multiply or division. This is a subtraction problem. So you have to FOIL x minus 4 times x minus 4, and when you do that, you end up with x squared minus 8x plus 16 is equal to 2x. Now as I'm looking at this, I'm noticing I've got a lot of x's all over the place, so I first want to try to get them combined as far as possible. I'm going to do that by moving this 2x over to the other side using subtraction. So I am left with x squared minus 10x plus 16 is equal to 0. Now at this point, you might want to try using algebra, but you've got to remember there's x in 2 spots, so that is not going to work for us. We have to use some of our resources from when we did quadratics. You can either use the quadratic formula, you can try to factor this using one of those methods, you could graph it and look for the x-intercepts. I'm going to go ahead and factor it. And to get x squared, I know I have to take x times x. The plus sign by the 16 tells me my signs match. This one tells me that they match as minuses. My factors of 16 are 1 and 16, 2 and 8, 4 and 4. As I'm looking through those, I'm going to pick the 2 and 8 because they will give me that negative 10 I want. You would want to FOIL this out to check it just to be sure. So when I FOIL this, you'd have x squared minus 8x minus 2x plus 16, and then x squared minus 10x plus 16, which is what we started with, so I've got it factored correctly. Now I take each factor, set it equal to 0, and I get my answers to be 2 and 8. Now I need to check these. When I go back in and I plug 2 into my equation, I end up with 2 minus 4, which is negative 2, is equal to the square root of 4. So I get negative 2 is equal to 2. Notice the problem I'm running into. Negative 2 is not equal to 2. Well, you might be asking yourself, but it's a square root, so don't we have plus or minus? Remember, when the square root is given to us, it is assumed to be positive unless there's a negative sign in front. This square root was part of our original problem, so it is only the positive part. So what do we do with this x equals 2 answer since it didn't work for us? We throw it out. This is one of those extraneous solutions where we did the math right, we did everything perfectly right, but we got a false answer. Now we need to go back and we need to check 8, because 8 could also be a false answer. So when I do 8 minus 4, I get 4, and 8 times 2 gives me 16. Well, the square root of 16 is 4, so I end up with 4 equals 4. Turns out that 8 works for us, so we would only keep the answer x equals 8. This one, we've got the square root of 4x minus 7 plus 2. Still follow the exact same process. I have got to isolate my radical. So I need to subtract the 2 off. So I have 4x minus 7 is equal to 3. Don't forget about your square root sign. And that 4x minus 7, I'm going to rewrite that with as an exponent. Make sure you put that 4x minus 7 in parentheses because the whole thing is being affected by the square root. And now I can look at this and I can raise it to my reciprocal exponent power. I'm going to have to raise both sides to the second or to the 2 over 1, however you want to think about it. And on the left side, this 1/2 and that square cancel each other out. So I am only left with 4x minus 7 on the left, and then 3 squared is 9. Now I've got a basic algebra problem. I'm going to add 7 to both sides, get 4x equals 16, divide by 4, and I get x equals 4. I need to go back and check it. So I'm going to end up with the square root of 16 minus 7, which is 9, plus 2, square root of 9 is 3, 3 plus 2 gives me a 5, which is what I wanted. So we get to keep this answer of 4.